Hi guys! In this video, we'll understand the new trick used by the sample to encrypt the data section and how we can decrypt it. In the previous video, we saw a function that set up some constants. It was called in the start bin very close to the beginning of the main program. Let's see something. Right in the beginning of the main function, we have a call to another function. We don't know yet what it is, but it receives two parameters on the stack. The first parameter is 772 hex, while the other one is an offset to the data section. This offset is right after the 16 bytes, which are used as an XOR key. Okay, so let's look into this function. Let's give it a more meaningful name. Remember, we had two parameters. The first one was the size of the buffer and the second one was a pointer of allocation. The value of the pointer goes into ECX and the second parameter into ESI. We have probably already recognized the block that performs the XOR. In 16 bytes chunks, here is the size of the block. There's no need to go in depth into the meaning of all these instructions. This portion of code will load the string buffer into EAX via the ESI register, block by block. Then it will perform this XOR operation on it. Very straightforward. Afterwards, it will store the buffer into EDI and modify the counters. The counter to the block size 16 is increased in EDX. Then ECX is decremented, which represents the number of blocks encrypted so far. That's it. A simple XOR routine. The key is the same that we've seen in the previous function, and it's stored in the first 16 bytes of the data section. So, basically what happens is all the bytes located afterwards will get XORed with a static key. This is a useful trick to hide the information in the data section from static analysis. Let us add a breakpoint after this function and run the sample. Here is the call. Don't execute it just yet. If we check now the data section, there's nothing interesting here yet. Press F8 to run the function and go back to the data section. After the 16 bytes, which represent the key, everything now looks like ASCII text. Another neat trick, we can convert these characters to meaningful strings. Press A to convert to ASCII. Or from the GUI, go to the Edit menu, Strings, and then select String. We have some more strings here. We'll do the same trick to convert all of them. Something very interesting here. We have a list of extensions of the file types. Then we have a message which looks like it's written in different language. Here we have an ICQ address, then more strings. Here, a random name. Probably this will be dropped by the sample. More functions here we don't care about now. Then we have the name of the text file, which probably contains the ransom note. How to decrypt files? There's a lot of information here. Also the extensions of the encrypted files. This message is very useful because it means that the sample can decrypt the files for us, very probably after we provide the decryption key, or if we pay the ransom and the author will give us the key. Make a mental note of this information because we'll use it later. All these interesting strings are now available. But if we end the debugger session, the strings in the data section will be encrypted again. So it's not useful for static analysis. What we can do is we'll extract the decrypted data and save it. We'll then load it as a segment on top of our static analysis. To do that, let's start the debugging again. Go to the decryption function. Make sure that everything has been decrypted OK. And after that, load an IDA script. Let's have a look at its content. The script has an output file named yellow-data.bin. We hard-coded the start offset to dump data 0040410. This one over here. This is where the decrypted data starts. Then we have the size. This was the first parameter to the function 772 hex. The script will just dump all the bytes to the file. That's it. Let's see how we can run this script in IDA. We'll go to File menu, then Script File, select it, and open. It's working on dumping memory. The file size here is 1906 bytes. Let's verify if it's correct using the calculator. So, .772 hex is 1906. So the size is correct. We can close the debugging session and then load the binary file on top of our analysis. Go to File, Load File, Additional Binary File. This is our file. Then we have to make sure that the load address is the correct one. So this is the load address. Very important here, the address needs to be in paragraphs. Because the size of a paragraph is 16, we need to drop the last hex digit. Also, make sure to uncheck the Create Segment option. Behold, the data segment has been completely overwritten with the decrypted data from the file. Save the IDA analysis and then we open the database again. Now the data section is in plain text, so we can do our static analysis much easier. We will see in the next video how to use these interesting strings to decrypt all the files. That's it for this lecture. See you in the final video. Thank you!